So it has to be clear to all of you. So good afternoon, all the students. So today we are into the sixth lecture of your subject, artificial intelligence. So we have already had 5 lectures, and we have covered near about 50%. We have covered the 50% of the syllabus, that is part 1 and part 2. Last time I gave you one very small assignment. It was about you have to write the features of two AI language. One was the Lisp, L-I-S-P, Lisp, and another was the Eclipse. So I will try that in this lecture also. I will give you very short, you can say, work, only of 5 minutes or 10 minutes. So because you are already in a 7th semester and you are just an engineer now, so you have to carry these things, little bit things yourself. So today's topic, what the today's topic is, very important topic, and that topic is one of the important, you can say, features of the human, that is we deal with. So just get behind and show you what that is. That is uncertainty. So today's topic is basically the overview of the broad topic is the uncertainty. So what is uncertainty? The thing which is not certain, the thing which is not known to us. And in our daily life, we come along many such situations which are uncertain to us, So we are not certain about those particular situations and how we have to deal with those situations. What are the different tools which are available with us to deal with the uncertainty? So the question is why we are studying this concept of uncertainty in the artificial intelligence. So basically, as I was already told you, that in artificial intelligence, the main objective is to make a machine which will behave similarly as the human being. It will do all the work which at presently humans do better. So yes, Sachin, what is problem? Sachin is raising hand. So please lower down. Now I will just wait 5 minutes more, then I will lock the meeting. So what happens, why we are studying this chapter is, as we have to make a machine which act as a human being, which does all the activities which at present human does. We want that our machine should enact as a human being. That is the artificial intelligence. We are incorporating the human intelligence into the machine. So as it is the behavior of the human, we in daily life we come across many such situations which are uncertain situations. One thing is there, we all are uncertain about our life. It is not known when our life will end. So it is the biggest uncertainty, and which is the truth also. So we have to deal with many such uncertainties in our life. What will be the result you will get? Because sometimes you are certain about that my result will in this range, but what proper result will be there, what percentage you will get, it is still uncertain. So how to deal with uncertainty? How human deals with uncertainty? Uncertainty is, what are the important words about the uncertainty? Some important words are ambiguous. Some situations are ambiguous. It is also uncertainty because we are not clear about that. Any unclear thing. Unclear thing. Then is vague. Anything which is vague, it is uncertain. Which is imprecise. This is also uncertain. So there are different words which defines the uncertainty. Their meaning is little bit different, but overall, all means there is a content of uncertainty. So how to deal? Some situations are ambiguous, not clear, they are vague, and sometimes we get the result, but the result is not precise. It is imprecise. So we have to deal with these types of uncertainties. So what are the different tools what we study in our syllabus? There are the two tools or two concepts through which we can understand the how to deal with the uncertainty. So those two topics that we will be covering today are under uncertainty. We will cover number one, Bayes rule, or also known as Bayes theorem, and second is fuzzy logic. So most of you might be going through these words first time. Most of you, maybe some of you have gone through these two words, but these are the new terms for you. One is the Bayes rule and another is the fuzzy logic. So these are the two concepts through which we will be dealing uncertainty in your syllabus, according to your syllabus. So we will first go with the Bayes rule, then we will go with the fuzzy logic. In a fuzzy logic, again, we will have two important topics. One is fuzzy set theory, and second is fuzzy systems. I have already uploaded the PPT for the Bayes rule and the PDF for the fuzzy logic or the fuzzy system on your ERP. So students are calling me. I have already told you that every content what I am teaching here, I am uploading it on your ERP. So you have to go to an ERP and in the academic section, you have to download all the PPTs and all the PDFs. I have also sent you the videos of all the search techniques and the game playing like min, max and alpha beta pruning and all the search techniques, the videos of all the search techniques, two videos. Some have one video and some have two videos on your WhatsApp group. So you have to go through all those videos also. So this is what is the content of today's lecture. So we will start with the Bayes rule. So in the very first introductory lecture of your AI, so we said that to deal with AI, we have to deal with many concepts or different languages, what we have done in the mathematics like probability theory or the probability. So we will make use of the probability theory in a Bayes rule. So Bayes rule is based on which theory? That is the probability theory. Suppose your father asks you how much marks you will score, what will be your result, then you give the probabilities that Papa, it will be more than 80% or it will be more than 90%. So it is not sure, but it is a probability. Somebody asks you, how will be the weather tomorrow? So you will give the probability. Even the weather forecast also they give 0.1% as that it may or may not happen. So they give the probability that this is a probability of rain tomorrow. So all the things which is uncertain. One tool to deal with uncertainty is the probability. We just have what is the probability of this thing to occur or this thing not to occur. Then according to that, we plan, we take the actions. So probability is one of the tool that human is making use to deal with the uncertainty. So same, if we want machine to act as a human, then machine should also have some tool like probability theory, which will deal with the uncertainty. So that rule, the probability theory, the Bayes rule or the Bayes theorem is based on a probability theory. So it tells about what is the probability of event happening. So probability is of two types. One is conditional probability and another is unconditional probability. Unconditional probability where there is simple or an event is individual. So what is the probability of even that it will occur or not occur? But conditional probability is if one event has already occurred, then what is the probability that another event will also occur? That is, if one condition is already met, then what is the probability of that another condition will also be there or not? That is conditional probability. So probability is also two types. One is conditional and another is unconditional. The dependence, when one event is dependent upon the another, then it is known as conditional. When one is not dependent, one independent event, then it is unconditional probability. But the Bayes theorem is basically the conditional probability. If I talk about the Bayes theorem, it depends upon the conditional probability. Suppose if a person is having a temperature, is having a fever, then what is the probability of that he is suffering from any flu? So if already there is a fever, one condition is already there, then what is the probability that that person, this fever is due to any flu? So this type of things comes under the Bayes rule or the Bayes theorem, that if one event has already occurred, then what is the probability that another event will also take place? So we have to see this in the Bayes theorem, that is the Bayes rule. It is very important rule. One thing in the beginning of Bayes theorem I want to tell you that it is also known as Bayesian theorem. Bayesian theorem or Bayes theorem. And on the basis of Bayes theorem or Bayesian theorem, there is one topic BBN, that is Bayesian belief network. Bayesian belief network. So this topic you will do yourself. Write down. What is BBN? Bayesian belief network. So Bayesian belief network is nothing. It is a network. It is a type of graph which is based on a Bayes rule or the Bayes theorem. It is a acyclic graph, a acyclic directed graph where nodes are there, vertices are there. What does node represents? Nodes represent, and what does edges represent? You have to see. This is the thing you have to see, that what is the advantage or what is the application of BBN, that is Bayesian belief network. This I will not cover today. It is a topic of only 5 minutes. Once you have done with the Bayes rule, then you can easily understand what is BBN. So you all note down along with list and clips. You have to do this also. BBN. What is Bayesian belief network? And there will be a question in assignment also. What I am leaving today is list and clips and BBN. So you have to, I will give you the assignment and you have to attempt this question in a assignment also. So come to the Bayes rule theorem. So simply Bayes rule is nothing. It is just dealing with the probability. What I have already told. Like when we, you can say toss a coin, then what is the probability of head or tail? When we just go through the dice, then what is the probability of coming 1, 2, 3, 4, 5 or 6? When we pick any card from a bunch of cards, then what is the probability that this will be diamond 8? So these are the probability. So we work with the probability. If number of occurrences of other, we have to see what are the number of occurrences of all the conditions. As the number of, as we take into account the card, there are the 52 cards. So probability of any card of occurring or picking up is 1 over 52. But in coin, the probability of head or tail is 1 over 2, that is 0.5. So this is the thing. And if one thing has already occurred, then what is the probability of another thing to occur? It may change, because if we take out one card already, then what is the probability of another card? So it will get changed. So this is the thing in a probability. If I say we have two dice, what is the we will throw, what is the probability that sum of the two dice will be 7, or the sum of two dice will be 8, the numbers which come on a two dice. So it depends upon what is the result of the first dice and what is the result of the second dice. So this is all about the probability. And there is the important, you can say, one formula is there for the Bayes rule, that I will share you with the in a screen. So I will share you the Bayes rule in a screen. So probability, it is basically on the probability. So probability is the measure of likelihood that an event will occur. So what is the likelihood that this event may occur? It is quantified as a number between 0 and 1. So probability is always between 0 and 1. If if it is not occurring, then it is 0. If it is occurring, then 1. And in between, there may be the probability. Just I have said, what is the probability of head or tail when we toss a coin? So it is 1 by 2. Similarly, what is the probability of picking a card from a bunch of cards? It is 1 over 54. So conditional probability, it is the measure of the probability of an event given that, or assuming that another event has already occurred. If the event of interest is A and the event B is known or assumed to have occurred, then the conditional probability of A given B. If B, what is the probability of one event if another has already occurred? So the probability of A under the condition B, it is written as P A over B. P A over B is, what is the probability that A will occur if B have already occurred? So what is the probability that event A will occur if event B has already occurred? So this thing is the conditional probability. And if we write only like this, PA or PB, it means it is unconditional probability, that what is the probability of event A to occur? What is the probability of event B to occur? So when to apply the Bayes theorem? When part of the challenge in applying the Bayes theorem involves recognizing the types of problem that warrant its use, you should consider Bayes theorem. Then the following condition exists within the sample space, because sample space is all the possible outcomes. So in the card, there are 52 possible outcomes, and out of that, one has to be taken into account. So within the sample space, so the sample space of all the different events that may occur in a card is 52. So there exists an event B for which PB is greater than 0. So main thing is what we have to see, that this is the condition, PA over B. So some history about this. The Bayes theorem was developed by Thomas Bayes in between, and he remained from 1702 to 1761. It shows the relation between one condition probability and its inverse also. So there in Bayes theorem, if PAB is given, then PB over A is also encountered in the same theorem. Means if we have to find this, then this should be known. This should be given. So we provide a mathematical rule for revising the estimate for forecast of light of experience and observations. So some simple examples are there. Ponder this question: does God really exist? So there are different ways. Some mathematicians say yes, some say no, some say probability is there. So it is just all the probability. It is also about what we say belief. What one believes in terms of when we talk about the dharam and religion and the God. So it is also depending upon the one's belief. So therefore, I shown that topic, that Bayesian belief network. What do you believe? On your belief, the probability depends. So this is very important slide. So I will stop here for 10 seconds, 20 seconds. You go through with this. This is the Bayesian theorem. This is the formula for the Bayesian theorem or Bayes theorem or Bayes rule. P A over V means what is the probability of A if B had already occurred. It is given with the formula P B over A, that is the inverse of that, into P A over P B. So individually you have to write what is P A over B. This is we have to find, and this is what is the probability of A to occur if B have already occurred. Then what is P B over A? It is given now. What is the probability of B if A already have occurred? So it is given PA, you know, probability of A to occur, PB, probability of B to occur. So you have to define. So this is the Bayes rule or the Bayes theorem. So Bayes theorem is mentioned of revising the probability given that additional information is obtained for any event. So if event have already occurred, A have occurred, B have occurred, and individually A have occurred, individually B have occurred, what is the probability of A to occur? And in conditional probability is also given, that what probability of B when A has already occurred. Now we have to find this. Sometimes the question comes, you have to see the statement, what is missing. So out of 4 terms, 3 will be given and 1 will be missing. So there can be numerical on a Bayes rule, which is based on a Bayes theorem. So where what A and B are the events. PA and P are the probabilities of A and B with regard to each other. Without means they are independent. They are without regard to each other. Means they are the independent events. Unconditional. PA over B is the conditional probability, is the probability of observing an event A given that B is already occurred or true. PB is the inverse of that. So Bayesian inference, so what we infer from here, what we reason out from the Bayesian theorem. So it is a method of statistical inference in which Bayes theorem is used to update the probability of hypothesis as evidence. So this is the hypothesis that some statement is given. Suppose I have given you the statement that tell me any statement that the village people are more educated or less educated. So it is a hypothesis. It is not the you can say proof. Now on taking onto account, you have to do the statistics. You have to go to the village, not one village, many villages. Then you have to acquire the knowledge. You have to do the surveys. You have to statistical collect the data. How many people are there? What is their education qualification? And you have to also compare with the near about urban areas. Then only you can compare that what statement, what hypothesis we have given, it is right or wrong. So any statement which is given and we have to prove it is right on, that statement is known as the hypothesis. Then we have to collect the evidence. The evidence is collected with the survey. We collect the data. Then we apply some statistical formulas on that data, and then we collect the evidence. Then we finally go to the result. In these cases, then we apply this thing. So what is prior and posterior? Very important. Prior and prior. The initial probability based on present level of the information. That is the prior. The initial probability based on the present level of the information is the prior. And what is posterior means a revised probability based on addition. So what is the probability you think in initial stage? That is known as the prior. But then you collect the data, you collect the evidence, then you apply the formula, then you revise that whatever you have said earlier, what was the probability you have got earlier, it is right or wrong, or what in the Meyer in the numerical form it has changed. So what is changed afterwards, after collecting the evidence, that type of probability is known as the posterior probability. So you can go through this simple example. So I will just wait for here for you just read this and you have to do it yourself. So some like these situations are given. So you have to apply the Bayes rule, and there obviously there will be values will be given. So you have to put on the values and do such numericals. So this is the solution. So these events are the mutually exclusive events. It rains or it does not. Additionally, a third event occur when the waterman predicts rain. So notation there was event below. So event A, it rains on Mary's wedding. It does not rains on Mary's wedding, and A2 and B is the waterman what predicts. So there are many. I have told you about the simple things like picking of a coin. Sorry, what will the result of tail or head when we throw a coin or toss a coin? What will the chances of picking 8 diamond from the bunch of cards? So these types of probability can be there. Are questions can be there. So see, he has solved that numerical. So he is using PB over A1, PB over A2, PA1 individually, PA2 because there are 365 days. So we have collected it rains 5 days out of this year. So this type of calculations we have to make. I will give you one numerical in your assignment also. So that will be the easy for you. So just you have applied all the values and just see the final result is PA1 over B is 0.1. So these are the some poll questions that I will deal you the later. So we have completed with the first topic of today's, that is the Bayes rule. Now I'll come to the second topic of today's, that is the fuzzy logic, and it is very interested in very simple topic. Very interested and very simple topic. That is no fuzzy logic I am saying. So what is the meaning of the word fuzzy? First of all, go through the meaning of the word fuzzy. Let me see if Seema madam have already joined. So wait for a second. Seema madam, have you joined? So fuzzy logic is a topic. First of all, we go through the word fuzzy. What is the meaning of this word fuzzy? So fuzzy means anything which is imperfect, imprecise, vague, unclear. So that is the meaning of the word fuzzy. I will just give you one situation. Let me draw some diagrams. So just look into the board. So first situation is this point is outside the circle. So it is true. Yes. What is the probability that point is outside the circle? It is 1. Yes, it is outside the circle. We can definitely very correctly say that the point is outside the circle. In this, if we ask the question, is the point inside the circle? We will say yes. If we say, is the point outside the circle? We will say no. Definitely, we can say yes or no. So if yes is 1 and no is 0, then in the probability graph, so its value will be either 1 or 0. The probability value will be 1 and 0 here, the probability value of 1 or 0. If the question is point outside the circle, so what? Yes, it will, yes, 1. The probability will be, well, it is inside the circle, yes, 1. It is outside the circle, then I will say no, then value will be the 0. It is on the circle, yes, it is on the circle. So up till now 1, 2, 3 are very simple. Now just come to the fourth diagram. Now this is, again I will draw it much properly for you. Just wait. So let me ask somebody from you. Anmol Singh, unmute yourself. Anmol,
Yes,
Anmol,
sir.
can you listen me?
Yes, sir.
Anmol, this is outside the circle. Point is outside the circle.
Yes, sir.
Definitely.
Yes, sir. Definitely after the circle.
Point is outside the
Inside the
circle.
circle. Sir, inside.
I am asking you the question. In second diagram, point is outside the circle.
No, sir.
No, you definitely it is not. In third, the point is on the circle. Just see here. The point is on the circle. Third diagram.
Sir, point कहाँ पे है?
See here.
Yes, sir. On the circle.
On the circle. Now in here, fourth diagram. Point is on the circle.
Yes, sir. On the circle.
Not acha, it is on the circle. No, not it is inside the circle. Just
Yes,
see.
also inside the circle.
So my
Sir,
question is,
ins
point is on the circle. Can you definitely say yes?
sir, it it will touch
It
on
is
side.
touching. It is touching, na? Now, what I am going to ask you here, you are definitely saying yes, it is outside the circle. Definitely saying yes, it is in the circle. Definite, you are definite that yes, it is on the circle. Now, are you definite? यहाँ पे
Yes, sir.
पक्का
It
है?
is inside. Inside. Sir. Sir, inside. है.
पक्का श्योर है? ये ऑन द सर्कल नहीं है?
Sorry, sir.
Hmm?
Sir, I am confusing.
Yes, I am confusing you. My main aim was to confuse you. You got ना confused? अब confused हुए ना यहाँ पे? अनमोल,
Hello.
आप confused
Hello.
हुए कि नहीं हुए? You got confused here?
Yes, sir.
So
A little bit
this
confusing.
is the situation, that is the confusion. You are not clear whether to say it is inside the circle or on the circle. You got confused?
Yes, sir.
This type of situation is known as fuzzy. Clear?
O- Okay, sir.
This is what I wanted to tell you. What does fuzzy means? So such situation is known as fuzzy. Such situation is known as fuzzy.
Fuzzy.
Clear हुआ?
Yes, sir.
अच्छा, एक और क्वेश्चन है आपको. Can you see these two items in my hand? One is the duster and one is the pen cap. Can you see? All of you. I will unmute Vaibhav Tripathi here. Vaibhav, I am unmuting you. I am allowing you. You unmute yourself. Vaibhav.
Hello.
Hello, Vaibhav. Can you listen me?
Hello.
Hello, Vaibhav.
Yes. Good
You are
afternoon, sir.
getting my voice?
Yes, sir. I'm
All
getting.
class, just listen. I am telling you what are the fuzzy situations. What does fuzzy term mean? Vaibhav, can you see this cap?
Yes, sir.
This is duster,
Yes. Yes, sir.
which is long.
Duster.
Duster is long. So what if I want that you should write one statement about the duster. What you will write? What you will write?
Duster is comparatively longer than chalk.
In very simple word, you will write duster is long. In this particular
Yes,
situation, duster is long. Suppose you write
long.
duster is long. Suppose you write. Clear?
Okay.
Now in this situation, you see
Hmm.
the bottle here.
Yes.
Now you will write duster is short.
Yes.
Clear?
Yes, sir.
Now,
It's
if somebody reads your these two statements, in first
okay.
statement you have written duster is long,
Long.
and in second statement you are writing about that particular duster only. Then you will write duster is short.
Short.
शॉर्ट ठीक है तो यहाँ तो डस्टर कुछ भी हो सकता है अगर ये सभी आप तीन फ्रेंड्स होते हैं ना तो वी आर कंपेयरिंग फर्स्ट विद सेकंड सेकंड विद द थर्ड तो इन वन स्टेटमेंट यू आर सेइंग दैट डस्टर इज लॉन्ग एंड अनदर स्टेटमेंट यू आर सेइंग दैट डस्टर इज शॉर्ट so is it not confusion if somebody reads this statement somebody reads this statement these two statements so
Yes, sir.
not get confused
Yes, sir. Definitely. If we are not
definitely
given any
so
comparatively,
So, can I will not say it is an ambiguous thing, something
yes,
ambiguous, something
yes,
not clear, it is very vague,
definitely, sir.
clear. So, this type
Yes.
of situations are known as the fuzzy situations or the fuzzy. Such type of things are defined with the term which is known as the fuzzy.
Fuzzy.
So, now I suppose you all understand what is fuzzy. So these are the situations where the things are not clear, where the things are not precise. There something is ambiguous, something is vague in nature. So those situations are all are uncertain. You are uncertain
Yes.
about what is the real condition of the duster, whether it is a long or it is a short.
Sure.
You are uncertain about the point, whether it lies on the circle or it lies in the circle. Clear?
Yes, sir.
So these type of situations are known as fuzzy situations. Clear? What up till now you have studied to deal with the uncertainty, what the probability? You have studied about the probability that 0 or 1 mostly and what are the in-between cases. So important thing is you have studied with the uncertainty up till now you were dealing with the one was the probability. Second is the you have done the classical set theory. आपने सेट थ्योरी किए सबने ऑलरेडी यू हैव डन सेट थ्योरी in your mathematics you all have done set theory so that set theory is known as the classical set theory so you all understand what I am telling in your lecture I will show you the PDF slides but I will just go through the slide very fast most thing I am telling you in the lecture itself so you have to go through this lecture I am giving you the slides I will show you the share screen the slides PDF slides are there on the fuzzy set theory but it is I will just go through it main thing is you understand here so classical set theory what we have studied up till that in a classical set theory you make a set there is a set A 1 2 3 4 5 so we say this one is the element of set A 2 is the element of set 3 is the element of set 4 or 5 if I say is 5 an element of set you will definitely say yes yes 5 is the element of set if I say 6 is the element of set you will say no 6 is not the element of set so how you will represent it is you represent with the membership function that mu x x is a member of A so is 1 a member of A yes is 2 a member of A yes is 3 the member of say A yes yes means 1 is 6 is a member of yes a member of set you say no so classical set theory tells you there are only two values of a membership. Either it will be a member or either it will not be the member. So there are only two values for the membership. Either it is 1 or either it is no, 0. That is yes or no, that is 1 or 0. But so up till now you were dealing with the classical set theory. So our first three situations of your circle, this situation, and this situation. if I ask the question according to classical set theory, this point belongs to the set. What is the name of the set? Name of the set is outside circle. Name of the set is outside circle. Now the question is, does this point A is a member of set outside the circle? Your answer will be yes or 1. Now the same question for here. Is this point A or B is a member of a set outside circle? Your answer will be no or 0, because point B is not the member of this set. The name of the set is outside circle. Now the question here also, this point is a member of a circle outside circle. You will still say no. So it is clear. But what about this thing? The set I am talking is outside circle. The name of the set is outside the circle. Name of the set is set outside circle. Now you make this and you draw the point like this. So the point is somewhat on the circle and most of the point is outside the circle. Now my question is the set D on the circle, or sorry, outside the circle? Is this the member? So you cannot say 1 now, because some portion is also on the circle. So according to the classical set theory, you do not have any answer here now. You cannot say 1, you cannot say 0, because some portion is outside, most of the portion is outside, and some portion is on the circle. But you, as whole point, if the point would have been this, definitely your answer will be yes or 1. But now the point is like such, just see on a board. So definitely neither you can say 1, neither you can say 0. So how to deal with this situation? Here comes the role of another set theory that is known as the fuzzy set theory. Before going to this, now one thing more about a classical set theory, it is also known as crisp set. Crisp set, because just see here this diagram. This point outside the circle, yes, 1. You have the crisp value of yes or 1. If the point is here, is this outside the circle? You say no. You have the crisp answer, or 0. No, it is not outside the circle. So you have the crisp values 1 or 0. So classical set theories have 2 crisp values, binary value, either 1 or either 0. So a element can become a member of a set fully, or it is not a member of a set. So answer will be 0 or 1. But in this case, we cannot say it is a member and we cannot say it is not a member, because somehow it is member and somehow it is not a member. Both the conditions are true. To deal with such situations, these situations are known as fuzzy situations. There where something is imprecise, there is ambiguous, some vagueness is there. So here we will deal it with the help of fuzzy set theory. So it is a fuzzy situation. To deal this, we need a fuzzy logic or fuzzy set theory. So what does fuzzy set theory says? Very important what I am going to tell you. All of you be attentive now. So fuzzy set theory says that anything can be a member of set. We represent, yes, this is a member of set, suppose. Then we also say, along with the element, we attach one more thing along with the element. So if there is a fuzzy set, it will be having some element. Suppose point A was there, in this case, point A. Name of the set is outside circle. Outside circle. Outside circle is a fuzzy set. So here point A is there, point B is there, point C is there, and point D is there. So if I am asking you point A, along with element, you will also write a degree of membership. Along with element in fuzzy set, you also write the degree of membership. So how to write the degree of membership? because there were 2 degree, either 0 or 1. But here the degree lies between 0 to 1. In fuzzy set, it is many valued membership. It is not a 2 valued membership. In classical set theory or the crisp set theory, it is 2 valued. But fuzzy set theory, it is also known as non-crisp. Non-crisp. Fuzzy set theory is the non-crisp. Here the membership lies between 0 to 1. Suppose the name of the set is outside the circle. Now A is outside the circle. Yes, the membership will be 1. Then setting element of this set B. So B is outside the circle. No, it is not outside the. Then its membership will be 0. C, it will be the 0.5. 0.5, half outside the and half inside. Half outside and half inside. So here in that particular, in your previous classical set theory, the C will be considered as 0 because C is on the circle. But if it is not totally inside the circle or totally outside the circle, it will have 0. But in fuzzy set, it is considered as 0.5 because it is half inside and half outside. So, and our set name is outside circle, so it is 0.5. Yes, half it is outside the circle. And in this case, point D, you will say point D is 0.9. The name of the membership is circle, fuzzy set is outside circle. So according to outside circle, this value D is 0.9, means 90% it is outside the circle, only 10% it is not outside the circle. So here we can deal, but if same situation comes with the classical set, how we will write in classical set? Just see. In a classical set, we will write A only. Sorry, yes, only A. Because only A is totally outside the circle, we will write A. Rest B, C and D could not become the member of a classical set whose name is outside circle. So in a classical set theory, according to that theory, only you can define this situation, because what is the name of the set? Outside the circle, and it is a classical set. It will be member only if value is 1. So its value is 1. So we can only show this. So these situations could not be shown in a classical set theory if the name of the set is outside circle. But see the power of the fuzzy set theory. So you can take into account all the points A, B, C, D. You can tackle all the situations, even the imprecise or ambiguous or vague situations into consideration. So this is the power of the fuzzy set theory, because along with the membership, along with the member, you also give the degree of membership, means percentage of membership. It is 100% outside the circle, so its membership will be 1. It is 100% not outside the circle, 0. Half outside, half inside, 0.5. 90% outside, 0.9. So whole percentage is divided on a scale of 0 to 1. So this is the power of the fuzzy, where you can deal with the imprecise situation or the vague situations. So let me ask some questions. Rupali, unmute yourself. Rupali.
Hello.
Iram is also there. Iram, you also unmute yourself.
Hello.
Sambhav Jain, you also unmute yourself. Shekhar, you also unmute yourself. So I have taken the name of 4 to 5 students. Rupali, Sambhav, Shekhar. So you can unmute yourself. I have given the permission. Let me give permission to all and ask one by one. So you can all unmute yourself. I have given the question permission. So first of all, Rupali, you tell me. Are you listening to me,
Hello.
Rupali?
Yes, sir.
Have you understood what I have said?
Yes, sir.
So what is the power of fuzzy set or the fuzzy logic?
Hello.
Hello, what is the power of fuzzy set or fuzzy logic?
Hello.
Yes, yes, I'm getting your voice. Tell me.
हेलो.
हाँ जी रूपाली बोलो.
हाँ जी सर.
मुझे बताओ फजी सेट की एडवांटेज क्या है? What is advantage of fuzzy logic or fuzzy set? Rohit Prasad, you come to action. Rohit Prasad.
Yes, sir.
Rohit Prasad, have you heard my lecture up till now?
Yes, sir.
So tell me, what is the power of fuzzy set now?
Sir, power in the sense like it is basically ranging from 0 to 1. Like it is for all the points values as well. It is not basically depending upon 0 to 1 concrete value as the classical set.
Yeah, Santosh Prajuli. Santosh, you can. Santosh. Santosh Prajuli. Shekhar. Shekhar is there. Simranjeet Kaur is there. So they are missing now. They are not listening to me. Shekhar, Santosh, Simran, Iram.
Hello.
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 हाँ जी कौन बोल रहा है? Is there?
Shekhar, sir.
हाँ
Shekhar.
Shekhar, tell me what is advantage of fuzzy set?
Sir, to identify whether the point lies in the circle or outside the circle. For example,
This is one situation what I have told you. So in general, what you will say? Write a
if
line on
we,
fuzzy logic for the fuzzy set. What you will write?
for example, if the point is on the circle, but it
I'm
not
not
look.
telling you to give the example. I'm telling you give the characteristics of fuzzy set. Write some line. Say some line about the fuzzy logic. Speak some line. Don't give me example. Sonia is there. Sonia, you be ready for the next question.
Yes, sir.
Shekhar, आप बोलो अभी. Shekhar, you complete.
Sir, to identify the point whether it is partially located along the.
Beta, you are just stuck to one example only. I'm not talking about the example. I'm talking about the simple characteristics of fuzzy logic or fuzzy set. Yes, Sonia, you tell me.
Sir, we can take into account all the values, like it is many valued.
All the values. Which type of values? Which are not taken into account with the help of classical set theory.
Yes.
So, which values does not classical set theory take into account? Now the question is which values classical set theory does not take into account? Means the values which are not clear, which are vague,
Yes.
which are imprecise, which are ambiguous, because classical set theory only takes into account the two situations, either yes or no, fully yes or fully no. If the situation is half or in some percentage, yes, somewhat true. Now the question I ask you, example, one statement was given that duster is short and another statement was given that duster is long. You have listened to this when Vaibhav was saying?
Yes. Yes, sir.
Now tell me, I'm just asking you the question according to the classical set theory. And my question is, does duster is long? What you will say?
Sir, we cannot answer this question using
Cannot
classical
answer.
set.
One statement is written, duster is long. In another statement, it was written, duster is
Short. In other statement, duster is long.
so. According to the classical set theory, you cannot handle this. situation. Clear है?
Yes. Yes.
Clear है? But now see how fuzzy will help you. All of you just see now how fuzzy will help you. Now we have three things. Again, three things. एक ये cap है. There is one cap. Then there is a duster. Then there is a bottle. Then there is a bottle. तो आप इसको सेंटीमीटर्स में हाइट लो, इसकी भी सेंटीमीटर्स में हाइट लो, इसकी भी सेंटीमीटर में हाइट लो. सपोज ये जो हाइट है, दिस इज 20 सेंटीमीटर, दिस इज 8 सेंटीमीटर, this is 2 centimeter. So you divide your whole, you can say, space between 0 to 20 centimeter. You divide your whole space between 0 to 20 centimeter. ठीक है? तो ये क्या आएगा? 10% हुआ, 2. ठीक है? 20 का 10% हुआ. ये 40% हुआ, 8. और ये 20 की हाइट 20 है, तो ये 100% हुआ. तो ये मेंबरशिप अगर मैं लेंथ वाली मेंबरशिप में लूंगा तो इस पे वैल्यू आएगा, बॉटल के साथ मेंबरशिप आएगी 1, लेंथ मैंने क्या बोला, लॉन्ग. डस्टर के साथ मेंबरशिप आएगी 0.4 और इसके साथ मेंबरशिप आएगी 0.1. कैसे आया? जस्ट सी. कैप. So you can get such situations and you have to solve. Cap height is 2 centimeter. Duster length is 8 centimeter. Bottle length is 20 centimeter. And your overall space is between 0 to 20 centimeter. ठीक है? तो जो कैप 2 सेंटीमीटर में आएगी, it will be the 0.1 यानी 10%. Duster 8 centimeter यानी 40% यानी 0.4. So this is for cap, this is for duster, and 20 centimeter, total length was 20 centimeter. So it will be 1.0 for bottle, that is 100%. Clear hai? So in this situation you can represent duster in classical set theory in a long. If the fuzzy set name is long, in classical set theory, duster could not, you cannot represent duster there. But here in a fuzzy set long, you can represent duster as a member of this set with 0.4. You can also represent cap, that is cap with 0.1. Then bottle with 1.0. So in fuzzy set, what we write the name of the member along with its degree of membership. Degree of membership. Now who finds this degree of membership? As here I have found myself degree of membership because I have divided the whole space into the 20 centimeter and according to the percentage. So there is some software tool. If it is done with the automatic tool of the fuzzy theory, there is one function which is known as membership function. The name of that function is membership function. So membership function is there who decides what degree of membership an element will have in a fuzzy set. It will automatically calculate if you make a software. Otherwise manually also you can see. So the question is, now see what is the power of fuzzy logic. Now the times all the researchers, earlier researchers, जो student research कर रहे हैं, PhD, MTech, they are all taking the previous researches into account, where only they were dealing with the exact situation of 0 and 1, and now they are converting all the researches into fuzzy research, where now we are taking all the points which were taking into account as the vagueness or imprecise. जितनी स्पेस में पहले रिसर्च हुई थी तो हम एक पॉइंट्स को मानते थे, तो हमारे पास क्लासिकल सेट थ्योरी थी. तो अकॉर्डिंग टू द क्लासिकल सेट थ्योरी वी ओनली टुक इनटू दोस पॉइंट्स इन द स्पेस इनटू अकाउंट एंड वी हैव मेड द स्टडीज व्हिच वर आइदर व्हाट वी डिफाइंड. जो भी हमने सेट का नाम दिया तो वो अगर उसके मेंबर बनते थे तो हम उनको ही डील करते थे. बाकी सभी पॉइंट्स को हमने निगलेक्ट किया और पूरी स्पेस की स्टडी जो रिसर्च की है उस हिसाब से की है. बट नाउअडेज हमारे पास फजी टूल आ गया, हम वो रिसर्चेस को दोबारा कर रहे हैं साइंटिस्ट, और जो पॉइंट्स उन्होंने छोड़े थे उन पॉइंट्स को भी कंसिडर करके फिर अब नई रिसर्च कर रहे हैं, और देयर फॉर यूर फाइंडिंग कि हमारे पास अब सिचुएशन उतनी नहीं है, जो इम्प्रिसाइज सिचुएशन थी पहले वेग थी, उनको भी अब हम डील करने के काबिल हो गए हैं। तो उसके लिए वो टूल क्या है, वो टूल है फजी लॉजिक एंड द फजी सेट थ्योरी। तो दिस इज द पावर ऑफ fuzzy logic or fuzzy set theory. So now the question, so what is the advantage of fuzzy set theory? What is the power of fuzzy set theory? Now I have given 2-3 different examples. Now you can say like this situation we cannot handle in a classical set theory, but this situation can be handled in a fuzzy set theory. The classical set theory has known as crisp set. It is having the two values only, two binary values 0 and 1. The fuzzy set theory is a non-crisp set. It has the value in the range of 0 and 1, and in a set along with the member we also write the membership function. There is no degree of membership, sorry, the degree of truth or the degree of membership. But in classical set theory we only write the member. जो member है वो 1 ही था, बाकियों को तो हम membership में लाते ही नहीं थे और set में दिखाते ही नहीं. But here we show in a set. Yes, all the points can be covered in a fuzzy set theory. It can deal with imprecision, it can deal with vagueness, it can deal with ambiguity. So all the things which are imprecise, vague, not clear, ambiguous, fuzzy is capable of dealing such situations. So have you understood, all of you? Anybody can unmute and tell me, have you understood?
Yes, sir.
Anybody having any doubt now? Just I am giving 2 minutes. Anybody can ask me anything. Up till now, what we have done about the fuzzy logic and fuzzy set. I have given permission to all to unmute. Anybody can ask me any doubt up till now. Yes, yes, say. Anybody want to ask me? Anybody? So I will give you 1 minute break. Just have a 1 minute break. So I will just share some screen with you about the fuzzy logic, what we have done up till now. Just wait. So this is what we have done up till now. So fuzzy set theory, the word fuzzy means vagueness, and it is different than the classical set theory where the membership is given as 0 and 1, but here the membership is given as between 0 and 1. And some words are used in a fuzzy like young, tall, good, high, because we cannot say how much young, how much tall. So if we are taking into account, if we have a group of people and in that group all are between the age of 1 and 40, in that particular group, uh, if we are taking into account group of people where all the maximum age is 40 and the minimum age is, you can say, 5 years. So in the scale of 0 to 50, you can, in the scale of 0 to 50, if the age scale is 0 to 50, the person with the 40 years of age will be having 0.8 value, and with the 5 years of age will have 0.1 value. So we can represent all the, but we can say yes, tall. Then how much is young? How much young? So the person having the less age will be more young. The person having the more age will be less young. So this is that you can distribute everything. So you cannot exactly say how young he is, how tall he is, how good he is. So this has to be dealt with the help of some degree. We have to apply some degree or to that particular member, and it is done with the help of fuzzy set theory. But in a classical set theory, if we say tall, then there is no definition of tall. So how much tall you cannot say. How much? So this is the thing which are not represented in a classical set theory, but they are represented in a fuzzy set theory. Like young, then we can have a degree with the young. Tall, how much degree of tall is there? So this is about the fuzzy set theory. I have already told you it is dealing with some words like vague, imprecise, uncertain, ambiguous, inexact, not clear. Then there is a classical set theories. In a classical set theory, we have the membership there. If set is A and X is the membership and X is the overall universe of any set A, then any member small x, it will be the 1 or 0. If it is the member of a set A, then it will be denoted as 1. Otherwise, it will denoted as 0. But in a fuzzy set theory, the membership is given with the help of membership function, where along with the member, we also attach the degree of the membership, and that degree is between 0 and 1 in a fuzzy set theory. So crisp and non-crisp, the classical set theory, which was done earlier, it is known as the crisp set because we have the crisp value either 0 or 1. We are very much sure about that this is a member of your set or this is not the member of your set. But here we are not so much sure. We only have the degree of membership in a fuzzy set. Therefore, it is known as non-crisp. And here membership function has an important rule because it tells you how much degree a member is belongs to that particular set. Just see tall. So in the classical set theory or the crisp logic, the figure at the left hand side. So at particular 1.8 centimeter height. So all the people, if he is 1.79, he will not considered as tall. And if he is 1.81, he will be considered as tall. Means just see, if any person having a height of 1.79 meter, he will not be considered tall according to the crisp set study because his membership will be 0. So, but see in a fuzzy logic in the right hand side diagram. So here you can see that non-crisp logic, how it gradually comes down the membership. So 1.79 height will be considered as a tall, but with the degree of 0.9. So it is used to capture the uncertainty. So just see again one more diagram in crisp set. There is a you can say very slope is fast, very steep is there, but in the fuzzy it is somewhat gradual, having a slope little bit gradual. So example, set of prime numbers. So set of prime numbers is an example of crisp set that gives 1, 2, 3, 4, 5, 7, 6 up to 12. It is given only the natural number taking into account natural number up to 12. So these are the if you are given the members, then you can simply say yes, it is member or not. Prime number, yes, it is a prime, then it is a member. 2, 3, 5, 6, 7, 11. They are the set of prime numbers. Between natural number between 1 and 12, the set of prime numbers is 2, 3, 5, 6, 7, and 11. So that is the crisp set. So fuzzy set, we have already done. A very important thing, a fuzzy set A. Definition of a fuzzy set. Just go through this definition. A fuzzy set A defined in universal space X is a function defined in X. Now X is overall, all the things. And small x is the one particular member, which assumes the values in the range 0 to 1. So how the fuzzy set is denoted? Just see here, it is denoted like this one. This, what I have highlighted. A is the name of the fuzzy set, X is the member of the fuzzy set, and AX is the degree of membership. Like here, this is one member, cap is one member, and 0.1 is AX of cap, that is degree of membership of A. First element is X and its degree of membership is AX. So this is the way to represent the fuzzy set. Just see the example. There is the set whose name is set small. Here these are the membership. One is the member of fuzzy set with degree of membership 1. 2 is also the member of fuzzy set small with degree of member is 1. 3 is also with degree of membership 0.9. 4, because just see, we are taking into set small. Now the number is increasing, the degree is lower. हमने सेट का नाम क्या दिया, सेट स्मॉल. तो 1 एक स्मॉल है, 2 भी स्मॉल है, तो उनकी डिग्री ऑफ मेंबरशिप क्या है 1. हमने रेंज लिया ऑल द नंबर्स बिटवीन 1 to 12. so all the numbers between 1 to 12, 1 और 2 प्योरली स्मॉल की कैटेगरी में आते हैं, तो उनकी डिग्री ऑफ मेंबरशिप 1 है. 3 थोड़ा सा बड़ा हो जाता है, उसमें से स्मॉलनेस कम हो जाती है, तो इट डिग्री ऑफ मेंबरशिप इज 0.9. 4 की डिग्री ऑफ मेंबरशिप इज 0.6. 5 की डिग्री ऑफ मेंबरशिप इज 0.4 and so on. So definition of universal space means all the things if we are taking into account all the natural numbers, so unka universal space will be infinite. That will be the infinite. Fuzzy membership. So this I have already told you, fuzzy membership is degree of membership which is given along with the element. So you can also make the fuzzy plot diagram also. The diagram can also be there. Just see one example here. There is the name of the set is small. So 1 is member, 2 is member. So how to represent in a graph? And see here 0, 0.2, 0.4, 0.6, 0.8 and 1. और यहाँ पे ये member से up till 12 because universal space is all the numbers between 1 to 12. So 1 having the membership of 1. देखो fuzzy set के ऊपर देखो set small. The name of the set is set small. Fuzzy set is given. First member is 1. Its degree is 1. So उसकी जो ग्राफ में लाइन है वो पूरी up till 1 तक जा रही है. Then come to 4. 4 की membership है 0.6. तो see यहाँ पे 4 को 0.6 तक लाएंगे. So this is how you can make a graph of also a fuzzy set. You can represent a fuzzy set in a form of graph also. There is a graph of prime numbers. So your all the members are 1 to 12. But 1 से 12 में वो आपका यूनिवर्सल स्पेस है. उसमें से प्राइम नंबर कौन से हैं? 2, 3, 5, 7 and 11. तो वो उनको 1 दे दिया, बाकी 1, 4, 6, 8, 9, 10, 12 ये प्राइम नहीं है तो उनकी वैल्यू उनकी डिग्री क्या है 0 है। तो दिस इज द वे टू रिप्रेजेंट। बट अगर आप क्लासिकल सेट थ्योरी करते तो उसमें आप सिर्फ 2, 3, 5, 7 और 11 को रिप्रेजेंट कर सकते थे। 1, 4, 6, 8, 9, 10, 12 को रिप्रेजेंट कर ही नहीं सकते थे ग्राफ में। तो ये डिफरेंस है, यहाँ पे हम दोनों को रिप्रेजेंट कर सकते हैं उनकी डिग्री के हिसाब से। तो दिस इज द जस्ट सी, इसकी ये रिप्रेजेंटेशन है। इट इज द ग्राफिक इंटरप्रिटेशन ऑफ फजी यूनिवर्सल स्पेस। एक फजी यूनिवर्सल स्पेस है 12 और उसमें सभी मेंबर है, 1 भी मेंबर है, 2 भी मेंबर है, 3 is also member, up till 12 is member, all are member, all having the membership function of 1. So all are represented with the clean height of 1 in the diagram. So your set can be finite and infinite. Like days of week, Monday, Tuesday, Wednesday, Thursday, these are the finite set. If I say all the natural numbers, then it is a infinite set. Very important topic now, fuzzy operations. What are the different fuzzy operations? Let us go with this. These are the fuzzy operations, like inclusion is there. First is equality is there, complement is there, union is there, and intersection is there. I will show you with the example. So this I will not go through the slide. This I will show you with the example. There is set A. I will make two sets, two fuzzy sets A, like 1, 0.2, 2, 0.3, 3, 0.4. One fuzzy set is this. Another fuzzy set is 1, 0.3, 2, 0.4, 3, 0.6. Now the first is inclusion. Set A is included in B or B is included in A. So it is always possible if one set is subset of another set. Means how to take the subset? Here we all the operations. Remember one thing: all the operations on a fuzzy set, it is carried on the degree of membership. It is not carried on a element, but these are carried on a degree of membership of the fuzzy set. So this you have to take into account. Just see the example of inclusion. Just see the formula of the inclusion. First of all, what is the formula of the inclusion? So just see what is the formula. Let A and B be the fuzzy set defined in the same universal space X. So their universal space should be same. Then only you can do all these operations. Means if these sets are union compatible. Union compatible means if they have same number of elements and their universal space is same, then only we can do these operations as in a classical set theory. So they should be union compatible. The fuzzy set A is included in fuzzy set B if and only if for every X, X is the degree of membership, X is the degree of membership of element. If for every X in the set X, we have AX less than or equal to BX. So if I say is A included in B. So now see, first member is 1 here, here the member should be same first of all. First see, both the sets are having same universal space. Yes, universal space may be defined as 1 to 12. Means all the numbers are between 1 to 12. Yes, here all the numbers are between 1 to 12. Now first see, here 1, here also 1, 0.2, 0.3. So 0.2 is less than 0.3. Here it is for 2, it is 0.3 and 0.4. Yes, 0.3 is less than 0.4. Then third member is 3, 0.04 and 0.6. Yes, Here the degree of membership is less for all the elements 1, 2 and 3. The degree of membership is less than the corresponding degree of membership in set B. Therefore, yes, A is included in B. Yes, A is included in B. Suppose यहाँ पे 3 का it would have been 0.1. Then here it is 0.4. Now this is not included. Now set A is not included. This due to this it is included. Due to this it is included. But 0.4 is not less than 0.1. Therefore A is not included. In second case A is not included. So it is clear, if degree of membership of all the elements of A is less than degree of membership of corresponding elements in B, then we say A is included in B. So it is also one property is if A is included in B, then it is not sure that B is also included in A until or unless they are equal. अगर ये भी 0.2 यहाँ भी 0.2 हो, ये 0.3 है यहाँ भी 0.3 है, यहाँ पे 0.4 है और यहाँ भी 0.4 है, तो then क्या होगा, A is included in B and B is included in A. Clear? So because it is less than equal to. So if degree of membership is less than the corresponding degree of membership in another set, then we say it is included. Then comparability, when the two sets are comparable, two fuzzy sets A and B are comparable if the condition that A is subset of B or B is subset of A holds. That is, if one of the fuzzy set is subset of the other set, they are comparable. If one is subset of another, then it is comparable. If this condition is not true, then it is not comparable. See the example. In set A, we have A1, B1, C0. In set B, we have A1, B1 and C1. Then A is comparable to B since A is subset of B, because every degree function of A, degree of function, degree of truth of A or every membership function is less than that of B. For in first A 1 1 it is less than equal to, then B is 1 and downward B is 1, it is also less than equal to 1. C is 0 less than 1, yes. So A is subset of B, therefore it is comparable. But in second case C, A1 B1 C 0.5 and set D is A1 B 0.9 and 0.6. So here C and D are not comparable because C is not a subset of D and D is not. Why C is not subset of D? Because here see 1 is 1 equal to 1 is 9. Now see here, this 1 is greater than this 9. So this does not become subset of D. Second case, this is 1 1 0.9, this is less, but 0.6 is greater than 0.5, so D does not become the subset of C. Therefore these two sets are not comparable. Means if one set is included in another set, then only we can compare. If none of the sets are included in one another, then we cannot compare the two fuzzy sets. Equality is if the degree of membership is same. Don't go to the screen, come to the blackboard. Whiteboard. So if I say A, degree of membership is 0.3. Here also, here it is 0.4, here it is also 0.4. Here it is 0.1, here it is also 0.1. Now these two are equal. These two fuzzy sets are equal because the degree of membership of all the elements are equal. 0.3, 0.3. For 2, 0.4, 0.4. For 3, 0.1, 0.1. So degree of membership are equal. So therefore A and B are equal. If any change is there, if it becomes 0.4, then we will say A fuzzy set A is not equal to fuzzy set B. And from the diagram also you can see if the height is same for all the elements, then it is equal. Complement. How to take a complement? Very easy thing. Just listen here. You will get the numerical on fuzzy set. So here A is this 0.3. What is A complement? A complement is 1 minus AX. AX means degree of function. Now just see. What will the complement here? A. Formula for complement is A is 1 minus AX. Now A is degree of membership. Just see here. So 1, what will the degree of membership here of complement set A? 1 minus 0.3, it will be the 0.7. For 2, 1 minus 0.4, it will be 0.6. For 3, 1 minus 0.1, it will be 0.9. So this is the degree of membership. That is the A complement. In A complement, what I have told you in the beginning, that while making all these operations, what you consider the degree, not the element, but its degree. Take into account. In complement, you minus the degree with 1. 1 minus the degree, this will be the complement. So for set A, this is fuzzy set A complement. Just take 1 minus this. What is the result? It will become this. So very easy operations of fuzzy set, and you can fetch 10 marks. Now if the question comes, you can fetch all 10 marks from these questions. Next, union. How to take the union? Just see how to take the union. For union, you have to take two sets into account with the same universal closure. So what is A union B now? Just see. You will write 1. First member is 1. In union, here the degree is 0.3. Here the degree is 0.4. You will take the maximum of the two. You will take the maximum of the two. Maximum of the two is 0.4. Second element 2. Here it is 0.4. Here it is 0.6. You will write 0.6. Then you take 3. So here it is 0.3 and here it is 0.2. So you will write 0.3. So maximum of the 2 degrees will account in A union B, and minimum of the 2 degrees will account in intersection A intersection B. A intersection B will be 1. Here it is 0.3, it is 0.4. So minimum is 0.3. Second element 2. Here it is 0.4, here it is 0.6. You will take 0.4. For third element 3, it is 0.3 and 0.2. The minimum is 0.t. So if A and B are the fuzzy sets with their given degrees and elements, this will be the A union B and this will be the A intersection B. In union, we consider the maximum among the 2 degrees, and in intersection, we consider the minimum among the 2 degrees. So just see here, this is very important formula, A union B X. So here X is the degree of membership. It is maximum from the membership of A and the membership of B. Whatever the membership is maximum, we will take into account. And in intersection, same formula is there, but the formula is minimum. You take into account the minimum among the 2 membership of AX and BX. Next, very important question comes on this difference. What is difference between the 2 sets A minus B? What is difference? Now just see the formula of difference. Very important. You have to learn the formula of difference. Just see, this is the formula of the difference. A minus B. It is minimum of A comma B complement. A minus B will be minimum of AX 1 minus BX. So you take the minimum among both these two. So this 1 minus bx is nothing but it is complement. So you will write minimum ax b complement x. So what is a minus bx? First step is you take the b complement, then you take the degree of a and the result of b complement. Among that, whichever is the minimum degree. Let us solve this example. You have to remember this formula a minus bx. That's the difference is it is minimum of ax comma 1 minus bx. Now this 1 minus bx is the complement of b. So two steps are there. If two sets are given a and b and you have to find a minus b, then first you take the complement of b complement of b. Let us do this. So this is set A, this is set B. You have to find A minus B. How you will do? So first step is find 1 minus B or B complement. What is B complement here? 1 0.6 because it was 0.4 here. So its complement will be 0.6. 2 0.4, 3 0.8. So now you forget this thing. Now you forget this. Now you have to take into account A and B complement. So what is A minus BX now? It will be the 1. Then whatever the minimum among the degree between A and B complement now. Which is minimum? 0.3. 2. What is minimum? Both are same. You can take anything. Then 3. It is 0.3 here and it is 0.8 here. So you have to take 0.3. So this is A minus BX. And what will be the B minus AX? It will, then you have to take the complement of A and then you have to proceed accordingly. So very important: inclusion, comparability, union, intersection, equality and difference. The question can be, you may be given some set A, B, C, D set दिया होगा. So you will be asked to perform some actions like find A union B. What is A union B intersection C? What is B minus D? What is C minus D? So any such questions can be there. That is the numerical problem. There will definitely be a numerical problem on a fuzzy set theory. You have to remember the formulas. Very important. I'm again saying you have to remember the formula. If you solve the numerical without writing the formula, your marks will be deducted. Your marks will be deducted. So I have many examples are given in the slide also, but I am giving you my examples, the simple examples. So you will be given set A, B, C, D, and you will be asked to do some fuzzy operations on those sets. So these are some fuzzy properties, like fuzzy properties on union. That first property is identity. What is A union phi? Phi means a null set. There is nothing empty set. So A union phi. When you have a union of A and its phi set, that is the null set, the result will be the A set itself. A union X. X is the universal space. So universal space is always higher than A. So what will the output? In union, we get the output which have the higher value. So higher value is of X. So A union X will be X. Then there is the idempotence property, means identity. Same. Idempotence property is identity property. Like A union A, it is A. Then A union B is B union A. That is the commutative property. You have to remember these properties. So you know that this is the property, but which properties, what's the name of which property, that you have to see. Means A union A is idempotence. You have to remember that it is idempotence. A union phi is A. It is identity property. You have to remember these properties, because question comes, what is, name some properties of the fuzzy operation with example. Associativity means A union B union C is A union B union C. Then same property, those were the union property. Then same properties for the intersection. A intersection phi is phi. In intersection we take the minimum. So among A and phi, minimum is phi. So output will be the phi. A union A intersection X. So universal space is higher than the any set A. Then minimum is A. So therefore A intersection X is A. A intersection A is A. A intersection B is equal to B intersection A. Then the associative property A intersection B intersection C is A intersection B intersection C. Some additional properties, De Morgan's law type A intersection B union C is A intersection B union A intersection C. So you can be given A, B, C, D and you may be asked to prove the distributive property. So in that case, you will first solve the left hand side, then you will write the distributive property, then you will solve the left hand side of the distributive property, then you will solve the right hand side of the distributive property and you will prove at the end that LHS is equal to RHS. Such questions can also be there. Means A, B, C, D set are given. First question is find the A union B. Second is what is A minus B. Third is prove the distributive property among A union B and C. A, B and C. Prove the commutative property among A, B and C or A, B and D. Such type of questions will be there in a fuzzy operations. So Cartesian product, this I will cover in the next lecture about the Cartesian product. This I thought today we will cover, but in the next lecture we will cover from this topic, that is the Cartesian product. We will do the some projections of any matrix, the fuzzy matrix, first projection, second projection and the total projection. Then we will do another portion of the fuzzy set theory, that is the fuzzy systems. So this will be covered in the next lecture. Now I will have a poll of what we have done up till now. Just see 2 or 3 polls will be there. So just attempt these polls now. Be ready, all of you. I will stop sharing the screen now. So I am launching the first poll. Just go through this poll. We passed, only 10 students have polled out of 52. All of you be fast. Up till now 30 students have polled out of 51. Thirty seconds more. 10 students still left. Are they missing? They are not attending. 8 left now. 6 left. After 10 seconds, I will end the poll now. 4 students are still left. So 47 have polled. And it is 51 students are showing. Means 3-4 students have missing. They have just logged in and they are missing. Let me end the poll now. So see the result of your poll. So the answer of first question was the probabilistic reasoning and 91% have given the right answer. The answer of second was conditional probability and 89-90% have given the right answer. Now come to the poll number 2. Question is, crisp set is based on only 2 values and fuzzy set is based on many values. Is it true or false? And second question is, set of prime number is an example of non-crisp set, fuzzy set, both of above or none of above. We have done two types of set, crisp set and non-crisp set. And fuzzy set is name of one type of those. So apply your brain for the second. Just see what is the name of fuzzy set. It comes into crisp set or non-set, non-crisp. And set of prime numbers. Are you sure that this number is prime or not? So if you are sure, then it is crisp. If you are not sure, then this is non-crisp. I'm going to end the poll on only half of you have answered. Be fast. Only 10 seconds left and 40 students have answered. 10 have still not answered. And afterward you ring me that, sir, hamara poll reh gaya, hamara poll reh gaya. So this is the chance. I have given more than 2 minutes for the simple question. And still 5 students have not polled. So I share the result. The first answer was true. Many of you have given 85% have given the right answer. The second answer was none of above because set of prime number is crisp set. So I have given non-crisp and fuzzy. Non-crisp and fuzzy are the same. So answer will be none of above because set of prime number is an example of crisp set. The answer will be none of above. And most of you have given the wrong answer here. Most of you have given the wrong answer in the second question, but the answer in the first question is right. Now the third poll, next poll. Again, there are questions on poll 3. Go through these questions. Bayes theorem was dealing with something, but here,
हेलो
hello,
सर, पोल शो नहीं हो रहा है, एक बार फिर से रीलॉन्च कर दीजिए.
I am relaunching poll 3. पोल 3 मैंने फिर relaunch कर दिया. First question is the value of the set membership is represented by discrete set, degree of truth, probabilities, or both. Start polling. 15 have done up till now. The time is running. The lecture is over, almost over. So give your response. Be fast. The next is the room temperature is hot. Here the hot word is crisp, or you can measure the exact hotness or not, or you measure the hotness in terms of degree. So if you measure in terms of degree, then it is a fuzzy. If you are not measured, then it is a crisp. So last 15 seconds for this poll, and 30 students have polled, 20 are still left. Be fast. So last 2 seconds, 43, 7 have left now. I'm going to end the poll. Be fast. So I'm sharing the result. The answer of first is both, because probability can also be represented and degree of truth is both. And the room temperature is an example of fuzzy set. The last poll for today, second last, I think so. Just see, I have launched the fourth poll. Very easy questions. Just waiting for your response. 15 have given response out of 50. So in the beginning, I have done that today's topic was uncertainty, and we can deal the uncertainty with. In the beginning, I have told the first thing which I have written on a whiteboard was we can handle the uncertainty with, and then I wrote the name of the topic for today. So 30 students have given response and 10 seconds have left now. Still 14 students are left. So we can deal uncertainty with, I have done two topics. One was the Bayes theorem and another, so Bayes theorem is dependent upon what you know. And another is fuzzy logic. So these are the two tools for uncertainty. Nine students left now. I'm going to end the poll now. So their result will not be counted in the internal evaluation. See the result. The answer of first question was both, because probability, that is Bayes rule is dealing with the probability, and fuzzy logic. So Bayes rule and probability both are, previous question also you have given the both answer, but here only 45% is given. And fuzzy system can handle both. It can handle the numerical data, it can handle the linguistic. So I'm going to launch the last poll of today's topic. Last poll of today's topic, poll number 5. Only 40 seconds will be given. Give your response very fast. Very simple question and one question only. Fifteen students have given response. Be fast, all of you. The question is, which is not a fuzzy operation? क्वेश्चन क्या है कि इनमें से कौन सा फजी ऑपरेशन नहीं है? ये क्वेश्चन है कि फजी ऑपरेशन कौन सा है. क्वेश्चन इज विच इज नॉट अ फजी ऑपरेशन. वी हैव डन मैनी फजी ऑपरेशंस नाउ. So which is not a fuzzy operation? So 17 students left. I'm going to end the poll. Be fast. You are still thinking now. Simple question it is. कि कौन सा fuzzy operation नहीं है? Which is not a fuzzy operation? Many of saying all are not fuzzy operation. Still 4 students left. So see your result. Answer was exclusion. So last two polls, poll number 4 and 5. I am not satisfied with the poll number 4 and 5. You are not listening, some of you. So okay students, this is all for today's lecture. Now in the next lecture we will cover the left portion of the fuzzy, that is some projections of the fuzzy logic and what is the fuzzy system, and we will also start with the planning. So next lecture will be completion of this topic and starting of the planning. Okay, bye for today all of you.